notice, I've already mentioned that the compiler has some built-in knowledge of this stuff. One reason for that is there's a hell of a lot of noise here, so we can do a bit better than that. We can clean up the way that we iterate this type which we're calling our functional encoding of IEnumerable. So we can define something called, let's call it for each, as an extension method. So this guy, we're going to be able to for each any of these IEnumerable 2's, and we're going to perform this action on it. Let's call that one next. So here we can pretty much get rid of all this code here, drop it in right there. And enumerate our source as we passed in, and rather than doing console write line, we're going to do on next. And with that, we get to move to this. Console dot write line. Okay. So some of you might be thinking, well, why don't we have support for each? We should be able to convince the compiler to allow us to use a for each like that over our new representation of the enumerable. What the compiler actually does when it sees for each, it goes and it takes a look at the definition of what you're for eaching over, like this thing, the type of that thing, and it looks for a method called getEnumerator. It's not actually tied to IEnumerable at all. It looks for a method called getEnumerator, and then on the thing that is returned from getEnumerator in that instance, it's going to look for the two methods, the moveNext and current. So it actually doesn't know about IEnumerable at all, which is kind of an extension point, what's known as duck typing. So you may also be thinking, well then, how come we can't have an extension method just like this on func of notification that returns called getEnumerator? The reason for that is historical. So when the C# compiler initially builds its abstract syntax tree, its representation of your code, it goes through a number of passes, and each one of those passes pertains to a particular language feature, so something like for each. So in this case, one of the early passes is looking for that getEnumerator. Extension methods were implemented much later in the history of C# to support lint. A lot of this stuff actually. So that pass comes later in time. So you cannot actually write an extension method that returns something that has moveNext and current on it because the compiler doesn't allow it for those reasons. Anyway, moving on. Let's just build one more. I like to call these generator functions. They're not exactly operators yet. We will come to operators. But let's have a look at something that we can call keys. So, keys. Let's say keys doesn't do anything. Right here we can say press escape to quit. You'll see when that message is printed, it's quite interesting. One of the aspects of IEnumerable, and particularly the IEnumerable revision that came along with Link, was this whole thing of laziness, which wasn't totally embraced before, but as a design concept, it's really embraced now. So really, as a design guideline, your IEnumerables should be lazy. So we're also going to be lazy too. So you will see when this thing's printed to screen, it suggests that we are doing things in the right way. So here we go. var key equals console dot read key, and we can say k key console key dot escape. If it's escape, what are we going to return? We're going to return a notification complete, and I'm going to type this one to chart actually. If it's not escape, then we're going to notification. Notification dot next of. I always forget this bit. K dot keychart. Keychart. So let's just have a quick look at that animation as well. Press escape to quit. Okay, well, I'm not going to do some typing. What's that doubling up? That's very odd. Oh, yeah, that's why. Okay, so obviously no great shakes, but we can escape to quit, and I just hit escape, and that's my final key to kill the program. Maybe I should clear over. Exit. There. Okay, that's just about it for that. I am just quickly gonna drop in 2 more operators, and for that I'm gonna not bore you to death. And we'll take them from here. So these are very basic, and you recognise them from IEnumerable to sort of existing IEnumerable, that is. Empty. So get the enumerator. The first time through, you're going to return the fact that there are no more items in the sequence, and return is kind of like a scalar value, right? So this is our chance to set up our loop state out here, and then when someone calls move next, we're going to check to see whether this is the first time someone's called move next, and if it is, we're going to return that value. If it's the second time somebody's called move next, we're going to say, well, sorry, no, we're confirmed. So we'll come back to those. So up to now, we can do enumeration, which is still fairly basic. Right at the start, I mentioned this thing is going to be, the thing that we're building must be queryable, right? So let's add some query capability with where. And font T to bool. Is this familiar to people? This notation, this extension method thing, and everyone's familiar with func of T, yeah?
Kind of, yeah.
Kind of.
Not used much, but yeah,
So
to a certain extent.
Func with a single type argument is a getter, as I was describing before. Everything that comes after the first argument is actually the sort of the parameters. Sorry, I've got that completely wrong way around. the last type is the return value of the function. Everything else is an input parameter. So if you are trying to perform a filter, what you want to do is you want to put every item in the sequence into this predicate, and by convention, if you return true, then it's past the predicate, otherwise you skip the item. So here we go again. This is going to be our IEnumerable. the numerator equals source. There we go. And here, believe it or not, well, true. If, let me make sure I do this right, r equals the numerator. So we've just called move next. If the result of that is that we've completed, we can just go ahead and return a notification complete of T. We don't have to do anything else. So we've had a next right at this point. So does this pass the predicate, the filter? If it does, then we're going to return a notification next of what did I call that thing? R.value. So do you see why there's a while true loop there? It looks kind of wrong. The fact is, you do actually want to continue chomping your way through the input sequence until you either get to the end of it or you get to something that matches your predicate, something that you can actually return. So don't forget that this thing is going to get called many times. Imagine that there are, I don't know, it's a sequence of 10 items and the first 9 are false, the last one is true. And your filter is select all the truths. You would only want to call this once, you would only want to call move next once to get to the thing that passes the filter. So in that circumstance,